In this video, let's discuss the theory part of the SD-WAN forwarding policies. Let's say on our site we have two Cisco routers, R1 and R2. And one of the business requirement of customer is that the Outlook and SAP traffic should go via the primary MPLS link. But if there are more than 5% packet drops on the MPLS link, then the traffic should switch over to internet link. So let's say this is MPLS and this is internet, and in the requirement says that the traffic normally should go via MPLS link, but if there are 5% packet drops, the traffic will switch over to the internet link. And this is assuming that this is the primary router on the LAN. In case this router is the primary router on the LAN, then traffic coming from LAN will first take the MPLS router, but if there are packet drops on the MPLS link, then the traffic will take the internet link. So this is what we have to configure. In case if it's Cisco, then we can apply a policy based routing PBR on this router, and we can set up a policy that match the incoming traffic SAP set next hop to MPLS, and we can probably create a complicated EM script to determine the packet drops on the MPLS link, and once it triggers 5%, we have to mention in the EM script to switch the traffic to internet link. But in case of Versa SD-WAN, this has been simplified in the platform itself by the vendor. So here I'm taking this same statement and I'm going to break it down into SD-WAN terms of Versa. So the statement is, my Outlook and SAP traffic should go to primary MPLS link, but if there is more than 5% packet drops on MPLS, the traffic should switch over to internet link. It's the same statement as last time. So here we are going to break these lines. So the first one is my Outlook and SAP traffic. We are going to match this in the SD-WAN policy, where we select the source, destination, applications. Here this line, but if there is more than 5% packet drops on MPLS, we will match this line and we will configure a SLA profile based on this statement. An SLA profile will monitor your latency, packet drops, MOS, jitter, forward and reverse loss, and circuit utilization. And whatever you mention as the trigger point, let's say I have mentioned the trigger point to be 5% packet drops. Whenever that trigger point is matched, then an action is taken. And what is this action? That action is defined in the forwarding profile. So the action is the traffic which is going from primary MPLS link should switch over to internet link, and this action is defined in the forwarding profile. In a network, different applications or different traffic have their different sensitivity towards the packet drops, latency, and jitter. For example, our voice traffic is sensitive to latency, but our internet surfing traffic is not sensitive to latency or packet drops. And at the same time, our business critical traffic is sensitive to packet drops. So based on the application and business requirement, we can make multiple SLA profiles based on the application requirement, and we can make multiple forwarding profiles based on the multiple SD-WAN SLA policies that we are going to make. Next, let's see how these SLA profile, forwarding profile, and SD-WAN policy looks like, and we will take a theoretical look on these things. When we will log into our Versa director, we will see the format of SLA profile as like this. We will give it a name, we can give it a description, and here we can mention packet delay variation jitter, we can mention utilization, we can mention transmit and receive utilization, we can mention maximum packet loss, and here we can mention forward packet loss, reverse packet loss, and here we can mention the maximum latency or mean opinion score, MOS. This is the look and feel of an SLA profile, and we will configure, let's say if our requirement was for 5% packet loss, so we will configure 5% packet loss here. Next, we have forwarding profile. Forwarding profile, as we saw, it will switch the traffic from MPLS to internet when there is a 5% loss. So we will create a forwarding profile here. We will give it a name, description, and we have to attach the SLA profile that we have created. As we discussed, we can have multiple SLA profile and forwarding profile in our router. So we have to select the appropriate SLA profile that I have created for my particular application. So I will create my SLA profile and call it here. After this, in the SDWAN forwarding profile, I have to mention the circuit priority, so that when this SLA profile is triggered, then what is the action taken? The action is to switch over the traffic to the secondary link. So let's say in this case it says that the circuit priority 1 is of INET. That means by default the traffic will be traveling in the INET link, and once this SLA profile is triggered, then this router will switch over the traffic to priority number 2, which is MPLS. So we configured the SLA profile and we configured the forwarding profile. Now next is the SD-WAN policy. This is the example of an SD-WAN policy. Here we will create a policy and we'll give it a name. We'll mention the source, destination, and here we can mention header, application, user group, and once we define all those match criteria, we'll come to enforce tab, and here we will assign which forwarding profile this policy will be assigned to. So whatever traffic we are matching in this forwarding profile, let's say we are matching a particular traffic in default forwarding profile, this traffic will always have INET internet traffic as primary. So here, and for example, we have created a YouTube policy and maybe we are matching YouTube application. We will put that into the default forwarding profile, where in default forwarding profile internet is primary. So this is how we can manipulate our traffic based on the source, destination, application by making the SD-WAN policies. We will make SLA policies, SLA profiles to define the maximum loss, jitter, or utilization that particular application can handle, but if it's more than that, it will switch over. So let's see in the next video in practical.